Hello everyone, thank you for watching this video on the results of our study through investigating the effect of Earcon and speech variables on hybrid auditory alerts at rail crossings. This work was done in collaboration between Virginia Tech and Michigan Tech and funded by the Federal Railroad Administration. This work focused on highway rail grade crossings, which are areas of increased risk where highways intersect with railroad tracks. And although the Federal Railroad Administration has installed various warning devices, there has been a steady rate of accidents over the past 10 years. This is an issue as vehicle-to-train collisions are 20 times more deadly than vehicle-to-vehicle collisions. And as mentioned, despite the common countermeasure of installing more warning devices, this has not abated the risk of accidents and has become more expensive than it is worth doing in some areas. In past research, several projects and ventures have explored and considered the use of more dynamic, text-based or connected ways with a phone to alert drivers when they get close to crossings. And from our side, we have developed and investigated several auditory alerts that could play as vehicles get close to HRGCs. In a previous iteration of this subjective study, we had designed and evaluated three main auditory types: earcons, which are short synthetic tones; speech, as verbal messages;
Slow down, rail crossing ahead. Look left and right at crossing.
And hybrid sounds that combine both.
Slow down, rail crossing ahead. Look left and right at crossing.
Through our results, we were able to develop some guidance for HRGC auditory alerts near crossings for especially earcon and speech variables, and we're also able to determine that hybrid alerts outperform these types of auditory displays. However, due to the nature of the study, which had several alerts and a lot of variables to consider, we were not able to modulate hybrid alerts to a sufficient degree to be able to determine the ideal hybrid auditory alert that would play near HRGCs. Additionally, we had used text-to-speech to generate our speech clips and had found an effect of interaction effect of speech gender and participant gender, which we needed to verify and investigate using native English voices. For this study, we investigated 18 hybrid alerts and varied them based on earcon pitch contour with a flat, ascending, and descending pitch. Earcon speed was varied based on regular speed, fast, and slow speed, and we used both male.
Slow down, rail crossing ahead. Look left and right at crossing.
And female English voices.
Slow down, rail crossing ahead. Look left and right at crossing.
In total, 9 participants were recruited who were college-aged. In the previous iteration of the study, we had recruited 24 participants. However, due to the iterative nature of this study, we recruited less participants. In total, the procedure contained 3 main phases. First, after recruitment, we recorded basic demographic info from participants, such as age, gender, number of years with a license. Then, participants drove through a simulator drive that included HRGCs, rail crossings, and contextualized the situation as well as the nature of the alerts and how they would be used. Finally, we went to the subjective assessment where participants would listen and then rate alerts through various variables. There were 3 main clusters of variables determined through the previous study, which were the acceptance cluster, the safety, and the semantics cluster. For our findings, there was an effect of all three of our independent variables on various ratings. In terms of acceptance, Earcon speech had an effect on pleasantness and startle response, with a slower speed being associated with higher pleasantness, whereas regular or fast speed were associated with a higher startle response. Earcon pitch contour had an effect on startle response and desire to turn off, with a descending pitch being associated with a higher startle response, as well as Earcon pitch not being statistically significant enough to be able to determine pairwise comparisons within a adjusted Bonferroni correction, but descending and ascending pitch were associated with higher desire to turn off. Speech gender was influencing startle response and desire to turn off, with male speech, as seen with previous studies, inducing higher startle response, higher desire to turn off, however, not finding a difference in terms of pleasantness, which had been found before with female speech usually outperforming male speech. In terms of safety, Earcon speed, higher Earcon speeds were associated with much higher urgency, attention capturing ability, and commanding nature, as well as hazard level. Speech, gender, and male speech was associated with higher urgency, and pitch contour, although again not statistically significant enough for pairwise comparisons, did see that flat or descending pitches were associated with numerically higher commanding tones. Earcon speed, slow speeds again, underperformed their counterparts in terms of appropriateness, which might be due to a mismatch in expectations between the urgency of the situation and the perceived urgency of the warning when using a slow speed, which is why we recommend using a fast or regular Earcon for Earcon speed, a flat or descending pitch contour, although a descending pitch contour might need to be investigated further because of its higher startle response. And in terms of speech gender, with the main aim of our study to investigate whether there is again an interaction effect between participant gender and speech gender, we did not get that result and would recommend using either male or female speech, although male speech has been used more often with these safety alerts. In conclusion, we were able to examine and validate our previous findings, as well as further expand the body of knowledge on highway rail grade crossing IVAAs. We plan to conduct a driving simulator study to further evaluate our refined IVAAs, and we seek to design multimodal HRGC alert displays that can induce higher compliance and better driving performance near these locations. Finally, we would like to acknowledge and recognize the help from Michael Jones, who was our contact within the sponsor organization of the Federal Railroad Administration. Thank you for watching, and please feel free to add questions later.
Of all the subjective outcomes, which one do you feel the sound design should seek to optimize for this application?
So definitely, when we think of in-vehicle alerts, we immediately think about the safety outcomes like urgency, startle response, and the hazard level. Through our research, we found that in a way, all of them kind of play a role with each other. While we could focus on only the safety variables or the safety cluster, if there is a deficiency or a significant departure in terms of pleasantness or acceptance, our alert would not be as effective. So if there is any that we would optimize first, we would still seek to adapt, I guess, the urgency and the hazard level to the situation itself, as it plays a role into the perception itself of participants, plays a role into how they perceive it, how they feel it might be appropriate or not, or even how pleasant it might be or annoying. If it departs too much from the situation, people will provide much lower ratings anyways for semantics or acceptance.
Did you also consider changing the timbre of the alert sound or testing for that? How did you come up with that timbre to begin with? I might have missed that. I'm sorry.
That's a good question. The timbre that we've used is a timbre that we've used in a couple previous studies, even on rail crossings. We had not evaluated it previously in terms of different variations of it, which is why it was varied in this experiment, but it was generated through MaxMSP with a C5 note, and we generated it based on getting the frequency that we wanted and making it similar to airport or airplane alerts when they make their notification sounds. There's definitely a way in which the timbre can be varied, but this was kind of the alert that we had previously had good results with.
I understand. Is there a reason to believe that any of those factors would change given timbre? Would you expect the urgency of the alert to be affected by the timbre of the sound? Is it something, in your opinion, worth investigating, or is it more worth playing with the contour and the tempo, etc., as you did for now? Is there any indication there?
There is good reason to believe that the change in the timbre to something that's significantly different would affect the perception of both the alert, even if we change the pulse rate or the speed of it anyways, or the semitone. Though I would think, and still need to be investigated, I guess that would be a valid question, whether the change in perception based on the semitone variation or the pulse rate would be as big as we have found with this timbre. The most important thing being that when you use the timbre, you just make sure that it is adapted to the situation. The current one that we used, as it was for similar to an airplane notification, our goal for the alert itself was for it not to be too high in terms of hazard level perception, as the alert would be played at every crossing people encounter and should be more a way to notice or indicate, give caution to the presence of the crossing. So depending on the situation, if you need a more urgent crossing, I think you can also introduce a new timbre.